Hi guys, it's day 2 of our digital learning day. Yesterday when we had our video, we were talking about the different types of angles and how to name angles, and then we talked about angle relationships. So we talked about complementary, supplementary, and vertical. So today we're going to use those angle relationships and we're going to use them to be able to solve for missing angles that are inside of an angle relationship. So before we get started, yesterday I started to end the the video notes, with how to identify visually what it would look like if it was complementary, supplementary, or vertical. So I'm going to go over that real quickly again. So just keep in mind, remember that if it is a complementary set of angles, what you're looking for is that formation of an L shape. It's going to form what looks like an L. It might look like a letter L. It might be backwards L. It might be a upside down L, but it's going to make some kind of L formation. And just to keep in mind that when you're solving, you're going to take the two angles and you're going to add them and then set an equation equal to 90 degrees because that means it's complementary. The sum of the two angles is supposed to equal 90 degrees. So when you're setting up an equation, it might look something like this, where you have A and you have B and it's forming that L. You would then take A and you would add it with B and it would be equal to 90 degrees. And then you would solve for whatever missing value there might be. Okay, then we have the same thing for when we're talking about a supplementary pair. So supplementary is very similar, except instead of it being 90 degrees, it's going to be 180 degrees. And it's going to form what looks like a straight line. So it looks like a little straight line. You might have an angle that looks somewhat like this. This might be A and this might be B. But again, like I said before, you're going to add, and this time you're going to set it equal to 180 degrees. So that means you would be taking A plus B, and it would equal 180. Okay, then we have the third angle relationship that we talked about, which was those vertical angles. So for the vertical angles, you're going to have intersecting lines. Okay, and so maybe this might be A and this might be B. But with vertical angles, the important thing to know is that they're supposed to be equal, so you just set them equal to each other. Set them equal to each other. Okay, so that means in this case, A is just going to equal B, and then you can solve. Okay, so let's go ahead and take a look at a couple of little examples for solving some of these angles. So if I have the following diagram set up, maybe this is 2x plus 2 up here, and this is 130. Right off the bat, I want to look at the formation that I see. This is not an L shape. This is not a straight line. This is a intersection of two lines. So it's forming vertical angle pairs here. So I'm going to write that down below, that these are vertical angles, so that way I know the reason that I'm setting it up the way that I do. So these are vertical angles. That means 2x plus 2 is going to be equal to 130. So 2x plus 2 is equal to 130. So then we just go about and we can solve it, just like we would solve any normal equation. So the first thing that we're going to want to do is subtract 2. So we're going to subtract 2 from both sides. Remember, if it's a two-step equation, you have to get rid of this coefficient, or this constant first. You want to get rid of the constant. So instead of a plus 2, we're going to go ahead and subtract 2. So we're having to go all the way back to our equation unit on how to solve equations. So the plus 2 and the minus 2, they're zero pairs. They're going to cancel each other out. They're additive inverses. That leaves you with the 2x is now equal to 128. So then we have to check out next our inverse operation. So here our inverse is to subtract 2. And then our next inverse operation is to go ahead and get rid of this 2 that's attached to the x. Remember, when it's attached like that, that means it's multiplication. So the inverse of multiplication is division. So the inverse is to divide by 2. So we're going to divide by 2 on the left side, and then we're going to divide by 2 on the right side. 2 divided by 2, we'll go ahead and simplify it to where we have x all by itself. And then 128 divided by 2 is going to leave us with 64 degrees. So that means x is equal to 64. If you plug it back in, 2 times 64 plus 2 would give you 130. All right, let's move on to another example. So for problem 2, I'm going to set this up. Okay, so again, you want to look back up here. So this is my setup for my angles. You want to look back up here and see, okay, which set does it look like? Does it form an L? No. Does it form some straight lines here? Yes, it does form just a straight line. Those two angles together are going to make that straight angle. So that means that this is a supplementary set. And our supplementary set, we add the two angles together and set it equal to 180. So that means I'm going to come back down here. I'm going to add these two angles together because, again, this is supplementary. So I'm going to add 5x plus 115, and I'm going to set it equal to 180 degrees. So now here's my equation. 5x plus 115 is equal to 180. So then we just follow the process of solving these equations. The first thing that we want to do is the inverse operation to that constant. So instead of adding, our inverse operation is to subtract. So we are going to subtract 115 from both sides. Subtract 115, subtract 115. So by subtracting the 115 from the positive 115, that's going to leave us with 5x on the left side. And then 180 minus 115 is going to leave you with 65 on the right side. So now you have the equation 5x is equal to 65. We then have to perform our inverse operation here. And the inverse is to go ahead and divide both sides by 5. So we divide 5x by 5, which will leave us with just x. And we're going to divide 65 by 5, and that'll leave us with 13. So that means that x is equal to 13 degrees. Okay, so let's go ahead and move on to our next page. We're going to go to page 59. Real quickly, up at the top, I'm just going to go ahead and write down my relationships again, so that way I don't have to keep flipping back and forth. We know that complementary is going to set up the L, and that you're going to add the two angles together and equals 90 degrees. We know that supplementary is going to form that straight line. You've got A and B, where you add A and B together and it equals 180. And that our vertical angle relationship is where we have those intersecting lines. And that A would be equal to B. Okay, so I'm just real quickly going ahead and putting those there so that way I don't have to keep flipping back and forth. All right, so let's take our next problem. So right off the bat, I should make note of the fact that it is forming that L shape. So since it's forming the L shape, we know that it is a complementary set. It is going to be a complementary set of angles. So that means I'm going to take these two angles, I'm going to take that 2x minus 7, and I'm going to add it with the x plus 1, and I'm setting this equal to 90 degrees. So before I can even get going, I notice that I have multiple x values. I've got multiple constant values. That means we need to focus first on combining our like terms. So we need to combine the terms that are considered to be alike. So for example, 2x plus x. We know that those are like terms, so we have to do 2x plus, that's technically a 1x. When we combine those together, that is going to give us 3x. Then we also have the like terms of a negative 7. Remember that minus 7 acts like it's a negative 7. And a positive 1 or a plus 1. So that we have negative 7 plus 1. And when we work that together out, that's going to give us a negative 6. So notice I wrote the negative real close to that 3x because now I can say, hey, it's a minus 6. 3x minus 6. And that's going to be equal to 90 degrees. Now we just have our two-step equation once again. The inverse operation of subtraction is to go ahead and add 6. So we're going to add 6 to both sides. That's going to leave us with 3x is now equal to 96. Then our last step is to go ahead and divide by 3. So we'll divide 3x by 3, we'll divide 96 by 3, and we're going to get that x is equal to 32 degrees. Okay, from this point on, if you want to go ahead and pause after each problem to try it on your own, by all means, please go ahead and do so. So I'm going to draw out the problems. When I'm done drawing them, just pause it and you can try it. Or if you're not comfortable trying it on your own, you can just continue to watch the video the whole way through. But I do suggest that you at least try some of them on your own. Okay, so here's our next angle set. If I take a look up here, it looks exactly like my vertical angles. So I'm going to go ahead and identify that this is a vertical angle set. And then I'm going to go ahead and set them equal to each other. I'm going to take 3x minus 10 and set it equal to 50. And then I solve. My inverse operation of that minus 10 is to go ahead and add 10 to both sides. So if I add 10 here, I have to add 10 to the other side as well. That's going to leave me with 3x is now equal to 60. Then the inverse operation of a 3 times x is to go ahead and divide by 3. So I'll divide both sides by 3. That's going to give me x is now equal to 20 degrees. Okay, let's try problem number 5. So for problem 5, it's going to look like the following. Okay, so taking a look at this relationship, if I take a look up here, it looks like my supplementary set. I've got that straight line that's being formed. Yes, I do have intersecting lines, but they're not directly across from each other. They're side by side. Since they're side by side, you can ignore that bottom part right here and act as if it's just a straight line, splitting it into 2 angles, which would look like our supplementary set, which means we add the 2 angles together and set it equal to 180. So I'm going to take this measurement of 74, and I'm going to add it with the angle x over 2 plus 99, and I'm going to set that equal to 180 degrees. Now again, in a situation like this, the first thing we need to do is focus on combining those like terms. We need to combine any like terms that we possibly can, and in this case, the only like terms that we have are these constants. So that's 74 and that 99. Oop, and I misspelled combine. Okay, so I know I'm going to add 74 plus that 99 together, and that's going to wind up giving me 173. So I have 173. Then I still have that plus x over 2, and that's equal to 180 degrees. Now I can go ahead and start solving. So the first thing I need to do is get rid of that 173. Since it's a positive, I'm going to go ahead and subtract 173 from both sides. So if I subtract the 173 from both sides, that's going to leave me with x over 2 is now equal to 7. Okay, now this one is different. Normally we've had a coefficient, now we have a divisor. So the inverse operation of dividing is to go ahead and multiply. So we're going to multiply both sides by 2. Multiply by 2 and multiply by 2. So that gives me x by itself, and x will wind up equaling 14 degrees. Okay, I've run out of room, so I'm going to go ahead and go on to page 60 for problem 6, and we'll do maybe 6, 7, and 8. We'll just do a couple more. All right, problem 6. Now again, I'll just real quickly up at the top write down my relationships. Complementary. That means I'm going to add A and B together to equal 90. Supplementary. I'm going to add A and B together to equal 180. And then vertical. A and B are equal to each other. Okay, so for problem 6, so that's my setup, and that's a complementary set. It is an L shape. It's just a backward looking L, but it's still, an L shape nonetheless. So it is complementary. So I'm going to go ahead and add those 2 angles together and set it equal to 90 degrees. Okay, once again, I do need to focus on combining my like terms first. And in this case, my like terms happen to be the 4x and the 2x. So 4x plus that 2x is going to give me 6x. So I get 6x is equal to 90. And then I only have one operation to do. I just need to divide both sides by 6. And that'll give me x equaling 15. Let's try problem 7. Okay, in this case, these are vertical angles. So that means that they are set equal to each other. And one of the things that you need to make note of is that when I'm setting them equal to each other, I have a variable on both sides of the equal sign. So we talked about that. That was one of our last discussions on the equation unit, is how to solve if we've got variables on both sides. So when we have variables on both sides of the equal sign, we wanted to focus on the smaller variable. So we're going to move the smaller variable first. By addition or subtraction. So when we're looking at 6x compared to 8x, 6x is the smaller one. And since it's a positive 6x, we're going to subtract 6x from both sides. Okay, so 6x minus 6x is going to leave me with nothing. I have a positive 3 still. Then 8x minus 6x is going to leave me with 2x, and I still have that minus 17. And now we're down to a two-step equation. So we will add 17 to both sides. That's going to give you 20 is now equal to 2x. And then the last step is to divide both sides by 2. And you'll get x is then equal to 10. So x is equal to 10 degrees. So that's what x is equal to. X is equal to 10 degrees. What if I wanted to know what does the angle equal? So let's pose that as a question. So what does the angle equal? So if I know what x equals, then I can figure out what the angle equals by substituting x in for, or substituting 10 in for my x's. So right now, if I've got 6x plus 3, then instead of 6 times x, it's going to be 6 times 10 plus 3. Well, 6 times 10 is going to give me 60, and then 60 plus 3 is going to give me 63. And it does not matter which one of these angles you choose. If I chose the 8x minus 17, it's the same idea. 8x minus 17 means I'd be doing 8 times the 10 minus 17. Well, 8 times 10 is going to give me 80, and then 80 minus 17 is also going to give me 63. Those are equal to each other. Okay, so let's take a look at one last problem then. We'll do another one of the variables on both sides. Okay, so vertical angles. That means that we've got 5x plus 60 is equal to 3x plus 78. Now I need to get the smaller of the x's over to the other side, which would be that 3x. That's the smaller one. So I'm going to subtract 3x from both sides. That would leave me with 5x plus 60 is now equal to a positive 78. I would then subtract 60 from both sides. That's going to leave me with 5x is now equal to 18. Ooh, I'm so sorry. That shouldn't be a 5x. That should be a 2x. That's my bad. 2x. Make sure you fix that. And then we would divide both sides by 2. And we would get x is then equal to 9. And again, I could substitute that in. I could do 5 times 9 plus 60. 5 times 9 plus 60 would give me 105. Same thing if I did 3 times 9, which is 27, and add 78, I would get 105. Okay, go ahead and make sure you complete your activity for your formative assessment based off of solving for angle relationships.